I've given the clue whether you were identifying the test vector or using the test vector you are doing something. Which option will be right? First one or second one? Recollect what you did in differential, row test detect, concurrent, deductive. What is given to you? To perform a deductive fault simulator, what is the input given to you? Tell me. Shall I point out and ask? Nobody is answering.
We have the initial test vector. For that, we find the true value, and then with the fault, what is the value, and then we compare.
Anusha, once again, Anusha, tell me.
Using the test vector, we find the true value for that particular test vector, true value output, and then use when the fault is introduced, we find the output when with the fault one.
What is the output? Whether the particular test vector is able to detect the fault or not. Is that the output?
Yes, ma'am. If it is different from the true value, then it will be able to. So we compare and then check.
Yeah. So are we checking that status? Whether it is testable or not?
Yes, ma'am.
Yes, ma'am.
Okay. In that case, what is the input given to you? You are given with a circuit, you are given with a false, and you are given with a test vector. Am I right? Am I right,
Yes,
students?
yes,
So you are given with three things. First one is you are given with a circuit. It can be combinational or a sequential. Sequential means you have to definitely use differential fault simulator that you all know. So you are given with a circuit, and even they have given you the test vector. And in a deductive and concurrent, we didn't give you even the false. These two are enough for you. One circuit and one test vector is enough for you to go ahead with the deductive and concurrent fault simulator. These two simulator, the way it works, it will tell you what are the faults this particular test vector will detect. Other fault simulators, how it works is you will be given with a circuit, you will be given with a test vector, and you also will be given with one or two faults in that circuit. So using that fault simulator, you were able to test whether that particular fault is testable with that particular specific text vector or not. So you were getting an idea, like the particular this test vector detects which fault. Accordingly, you can cut sort the test vector which you want to use during the testing process. In 100 test vectors available, you can come up with only 50 test vectors, which is giving the maximum fault coverage. So that will be enough. So for that reason only, we were using or going ahead with a fault simulator or a true value simulator, all these things. You all know this simulation is done before fabrication. There is another set of algorithms available that we call it as ATPG algorithm. There is another set of algorithms, we call it as ATPG algorithm. Automatic Test Pattern Generation Algorithm. ATPG stands for Automatic Test Pattern Generation Algorithm. So this algorithm will automatically generate the test vector. Otherwise, I can say these algorithms are used to generate the test vector. So that means if I want to use these algorithms, I will be given with a circuit and I will be given with a false. I will not be given with the test vectors. So using this algorithm for the given circuit, for the specified the fault, which test vector will test that fault, I can identify. So these algorithms give us the output. The output will be test vectors. This is one way of dealing with this. So even if you go with this ATPG algorithm, finally I will come to know for these particular faults, these are the test vectors which I can use. So only those test vectors which is having the maximum coverage, I can use it. So the solution, I can get it in two different ways, either by using a true value and false simulators or by using the simulators which support ATPG. which is based on ATPG. Any one we can use it. So remember, for the true or a false simulator, you will be given with a test vector, false, and a circuit, all the three. So what you will do there is to identify whether a particular fault is testable by a particular test vector or not. That is your job there. That will be the output you will come to know when we use those simulators. But here, understand the difference. But here, you will be given with a circuit. You will be given with a test false. That's it. So when I run this ATPG simulators, the simulators which support ATPG algorithm, I will get to know that the fault present in the circuit is testable by this test vector. The answer from this ATPG simulators or ATPG algorithm will be the test vector. Is it clear, students? So ATPG algorithms are used to generate the test vector for the given circuit and for the given specified fault. The process of generating generating patterns to test a circuit, which is described strictly with a logic level netlist. Remember, this algorithm I can use if my circuit is in the gate level modeling. If it is there in any other modeling, I cannot use this ATPG algorithm. This algorithm usually operate with fault generator program. Fault generator program here means the program which is same as the fault equivalence and dominance. Fault generator program is nothing but the fault equivalence and dominance program. What is the benefit of fault equivalence and dominance program? It's written there, which creates a minimal collapsed fault list. That means in a circuit, if 75 faults are possible, means using my fault equivalence and dominance, I can reduce that 75 to 50. Do you remember? This is what we did. Do you remember, students? Do you remember?
Yes, ma'am.
This is what we did, right? 1 minute.
Yes, ma'am.
Is whether when I change the slide, is it changing now? Just a minute. What is the 1 minute? Yeah. So fault generator program is nothing but fault equivalence and dominance methods. So using fault equivalence and dominance method, I can reduce the total faults which I need to test. And that list and the circuit, if I give it to the ATPG algorithm, my ATPG algorithm will give me the set of test vectors which can detect all those faults. So this algorithm is used for multi-purpose. What is that multi-purpose? One thing I told you, this algorithm is used to generate the test vector, correct? For the given circuit and for the given fault. What is the other purpose of this ATPG algorithm? Using this ATPG algorithm, I can even identify redundant hardware present in the circuit. Now you need to recollect what we discussed about redundant hardware, redundant fault and all. So in any circuit, I told you already, few blocks, few signal lines, or few circuit, chances are there they can be redundant. That means they can be unnecessary, not required at that particular circuit. If any fault present at that particular site is said to be a redundant fault. So using this ATPG algorithm, it's not only I can only generate the test vector, I can even identify any redundant blocks present in a circuit so that I can remove it. So ATPG algorithms are used for two purposes. One is to generate the test vector. Another one is to identify the redundant blocks and to remove it. Clear? These are the two benefits of automatic test pattern generators. There are two types of automatic test pattern generators. Automatic test generators used for combination circuit, automatic test pattern generators used for sequential circuits. So automatic test pattern generators, which are used for combination circuits, we are going to now discuss. So ATPG algorithms, which are used for the generation of combinational circuits, there are totally 6 ATPG algorithms. Boolean difference symbolic method, path sensitization method, D algorithm, PODEM, fault table method, ENF method. So these are the 6 ATPG algorithms which are used to generate the test vector for any given combinational circuit with a fault specified in it. Clear? So now we need to discuss one by one all these algorithms. Students, is it clear what is ATPG algorithm? Algorithm used to generate the test vector. For this algorithm, as an input, you will be given with a circuit and also the faults. And using this algorithm, I can identify the test vector which detects that fault. Clear, students? And this process is done before fabrication. This is an alternative for fault simulators. Either I can go with a fault simulator method or I can go with an ATPG algorithm method. So shall we discuss? The first one, Boolean difference symbolic method. So now I'm going to explain this algorithm, Boolean difference symbolic method. So first step, this is a circuit given to you. Remember student, this is the circuit given to you. What else I told? You need a circuit and also you need a, for this algorithm, false. So here, one fault is specified. One fault is specified. Remember, in all these algorithm, Boolean difference of ODEM or D algorithm, you have to identify the test vector by introducing faults one by one only. No other option. Multiple faults I cannot introduce and I cannot come up with one test vector which will detect all the faults. That is not possible. In all these combinational circuit ATPG algorithms, I can get the test vector for one fault in the circuit. Then after identifying the test vector, I can remove this fault. I can introduce the next fault. I can get another test vector for that fault. It may end up with same test vector. That can happen. Suppose in this case, I have introduced here fault stuck at 0 at B. Suppose for this, my test vector is 0, 0, 1, 1. I got my answer as 0, 0, 1, 1. Next, I will remove this. Let me introduce stuck at 0 fault at C. For that fault also, I can get 0, 0, 1, 1. That is possible. So finally, after testing all the faults, I have to sort it out. Which fault is covering the maximum and I will take it. But all these algorithms supports to get one specified fault in the circuit, that you remember. For each and every fault, you have to run this ATPG algorithm repeatedly. So now in this circuit, they are given with a fault stuck at 0 at B. First step in Boolean difference symbolic method. First, you need to get the expression for Y. Whether the expression, whatever is given in the slide, is it right? Final Boolean expression for the output you need to first get the Boolean expression. Is the Boolean expression right for the given circuit?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. AB plus CD whole bar. Okay. First, I need to get the expression. Second step. Next, dou Y by dou B. Why B? Because fault is present at the B. Remember, fault is present at the signal line B. Output is Y. So we have to write like this: dou Y by dou B is equal to YB of 0 output with respect to the fault at B 0 XORed with YB of 1. So that means YB of 0 means this is my Y expression. Here I need to substitute B as 0 and find out what is the expression I'm getting. So what will be the expression, students, tell me, if I substitute B as 0 in this expression?
1, ma'am. 1.
Is it 1?
CD bar, CD whole bar.
CD bar. If B is 0, this term, first term will become 0, so I will get CD bar. Next, for yb of 1, I have to substitute b as 1. If I substitute b as 1, what will be my y?
A plus CD bar.
A plus CD bar. So substitute. Why I took B is because fault is present in the primary input B. So that's why I have taken B. Okay. So YB of 0 XORed with YB of 1. So YB of 0 will be CD bar. YB of 1 will be A plus CD bar. Now this you substitute here, XOR it and get me the simplified expression. Everyone solve it. CD bar XORed with A plus CD whole bar. When you XOR it, what is the final expression you are getting? Dou Y by dou B. Simplify and tell me what you are getting. Please everyone solve. Fast also. CD bar XORed with A plus CD whole bar.
A into CD.
A into CD. ACD then.
No, ma'am. CD whole bar.
So final dou Y by dou B is CD whole bar.
A into CD bar. For CD bar is in.
A into CD bar. Others? Still, can you simplify? CD bar, can you write it as C bar plus D bar? See, one more thing. The dou Y by dou B should be in sum of product terms, SOP form. One constraint here is always represent dou Y by dou B in SOP form. So whoever gave the answer now, represent that in SOP form and tell me.
AC bar plus AD bar.
Yes, AC bar plus AD bar. Others, anybody else getting the same answer?
Yes, ma'am.
So remember, dou Y by dou B should be in which form?
SOP.
SOP form. Okay. So you will get dou Y by dou B AC bar plus AD bar. Okay. Next step. Fault is at B and the fault is stuck at 0 fault. If the fault is stuck at 0 fault, I need to multiply B with dou Y by dou B. If the fault is stuck at 1, I need to multiply B bar. Remember, fault is present in one particular signal line. If the fault is 0 means the signal line as such you need to multiply. If the fault is 1 means complement of that you need to multiply. In this case, fault is 0. So I need to take this variable as such. So B into dou Y by dou B. So already I got AC bar plus AD bar. So to that I need to multiply B. So A, B, C bar. When you write this, always write it in an order because A, B, C, D. So A, they don't write A, C bar, B. Write it in an order. So A, B, C bar plus A, B, D bar because I'm multiplying with B since the fault is stuck at 0. If the given fault is stuck at 1 at B, then I need to multiply with B bar. Then it will be A, B bar, C bar plus A, B bar, D bar. Now coming to the stuck at 0 fault, it is B. So I multiply. So I got this. Next, I need to get the test vector last step. A is normal form 1. B normal form 1. C bar, so 0. D is missing. Actually, in this circuit, there are 4 inputs. A, B, C, D. D is not here. So X. Another test vector is A is 1. B is 1. C is not there. X. D bar, so 0. So these are the test vectors which will detect this fault. So this X can be 1 or 0. So different test vectors are 1, 1, 0, 1, 1, 1, 0, 0, and 1, 1, 1, 0, 1, 1, 0, 0. So these are the 4 test vectors which can be used to test this fault. Is it clear, students? Any doubt here? This algorithm is very easiest one. Is this clear? And remember, Boolean different symbolic method I can use if fault is present in any one of the primary input. I cannot use this method if a fault is specified in any intermediate node or at the output. I can use this algorithm only if the fault is specified in the primary input. If I say fault is a stuck at 1 fault, then what will be the test vector? Tell me. In terms of X, you
One,
tell me.
1, 0, 0,
1, 0, 0, X.
X, S, ma'am.
Other
Next,
one?
1, 0, X, 0, 1, 0, X, 0,
10 x0.
Yes, 1, 0, X,
X, 0.
Clear? How to do this? Is it clear, students, how to do this?
Yes, ma'am.
I'll start with another thing. So have you copied this? Everyone? Have you copied this? So you know how to do. Next problem. Copy down the circuit, everybody. Copy down the circuit. Only this, the fault you take it is at C. Don't take it in the fan out branch. Only change this fault, you take it here. Are you able to see? At the input C. Don't take it in the fan out branch, take it here. But this circuit, you need to solve it for C stuck at 0 and also stuck at 1. C stuck at 0 and also stuck at 1. Everybody, please copy down the circuit. Everyone, please copy down the circuit. If you have copied down the circuit, question is get the test vector using Boolean different symbolic method for the stuck at 0 and stuck at 1 fault at the primary input C. Stuck at 0 and stuck at 1 fault at the primary input C. Have you copied the circuit? Say yes or no.
Yes, ma'am.
Yes, ma'am.
If you have copied the circuit, what is the expression for Y? That is the first step.
AB plus BC plus CA.
AC plus CA.
AB plus BC plus CA.
AB
Okay.
plus BC plus CA.
Okay, you got the expression. Next, dou Y by what it should be? Dou Y by dou C. Dou Y by dou C is equal to YC of 0 XORed with YC of 1. Correct? YC of 0 XORed. Sorry, I didn't, by mistake, it is XOR, yeah. In hurry, I didn't, I made it plus. It should be XOR. Students, sorry, this should be XOR. This would be XOR. XORed YC of 1. So tomorrow, so next class, I want you people to complete this problem. YC of 0 XORed with YC of 1. So you will get an expression. And if it is stuck at 0, you will multiply with C or C bar. Stuck at 0 means
C bar.
CC.
Somebody
C,
told
C.
C bar. Stuck at 0
No,
means C. Who's
no,
that?
no, I'm doing a stuck at 1, ma'am. Stuck at 1, ma'am. Stuck at 0 is completed.
Okay. Stuck at 0 means, remember, you have to multiply with C. Stuck at 1 means you need to multiply C bar. Okay. I want you to complete C also. B stuck at 0, stuck at 1 also I want you to complete. I need the test vector for all the 4 faults tomorrow. Next class. Okay. This will take some 5 to 10 minutes. That's it. Students. Yeah. What is the doubt?
That C1 only for the middle gate only stuck at 0, ma'am. But the third gate C is normal one only, ma'am. The next question.
Next question.
AB plus BC plus CA. Yeah.
AB plus BC plus
Stuck
CA.
at 0 only for second gate, no, ma'am.
No, it is there for second gate or first gate or third gate. That we need not consider. We have, see, I told you fault is, I asked you to consider the fault at the input C. Don't consider at this site.
Okay,
I
ma'am.
asked you to consider here. And if it is present at C, it is affecting only second gate and third gate. We will not see all those things here. The procedure is this. Wherever may be the fault. Fault should be in the primary input. Fault is present somewhere in the intermediate line or output. I cannot use this algorithm. Okay.
Okay, ma'am.
Any other doubts, students? So the next class, you need to solve it for B stuck at 0, stuck at 1, and the C stuck at 0, stuck at 1, and also the apply and reduce algorithm, which I gave in yesterday's class. All should be completed in Tuesday's class. Clear? Spend some half an hour time in another 4 subject. Will you do? Can you do?
Yes, ma'am.
Please solve it. Only then you will understand. This subject you need to solve. Only then you will understand. Okay. Thank you.
Thank you, ma'am.
Thank you, ma'am.